Let's take a look at question number 1 on our homework. All right, I see a couple people messing up on there. Let's look at the top equation. Let's graph the top equation in red. That one crosses at -2. And from that point, you're going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, right? So, and you could extend it using that same pattern, but the other direction. Now, is this a solid line or dotted line? Everybody should say dotted, right? So we're putting a bunch of dots, putting some arrows on there. Now, we either shade in one side of this red line or the other side of this red line. How are you going to do that? You're going to check a point like 0, 0 to see if it works, right? If it does work, if this point works, that means that all the points up here work. If it doesn't work, that means that all the points down here work. So you want to shade in where your answers are at. So let's check and see if 0, 0 is an answer. It's as simple as plugging in a 0 for x and a 0 for y. 0 is greater than, if you plug in a 0 right here, it's just going to be a -2 because 0 take away 2 is -2. So is this true or false? 0 is greater than -2. That is true, which means that your answers are above the red line, so you shade in everything up here, yay? Okay, so now we're going to go to the other one. This one is in slope-intercept form. You could put a +0 if you want to help you not get confused. So this blue one does cross at the origin 0, 0, and from that point, it does have the slope 1 over 1. So you're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And you could use that pattern backwards. And is this going to be a solid line or a dotted line? Solid this time. Okay, there it is, a solid line. Now we still need to shade in either the top part or the bottom part of this blue line. Now the thing is, you cannot use 0, 0 on this blue line because 0, 0 is on the blue line. You need to pick a point that's either on one side of the line or the other side. You want to pick a point that's either on this side or on this side. And it could be any point you want. It cannot be 0, 0. It can't even be 1, 1 or 2, 2 or 3, 3 because all those points are on the blue line. So pick a different point. Look, you could pick any point, like you could pick this point or this point right here or this point right here, whatever. So let's say this one, 1, 2, 3, 4, +1. Let's go with 4, +1. There it is, 4, +1. That means you're going to plug in a 4 for x and a 1 for y. So this guy, if you were to plug in a 4 for x and a 1 for y, instead of y is less than or equal to x, it's going to be 1 is less than or equal to 4. What do you think of that? True statement. So what do you know about 4, 1? It's an answer. That means that all your answers are below the blue line, along with that 4, 1. Now what really matters is just your overlap piece. Now that's where it's this little area between the two, between the blue solid and the red dotted. That's your answer. If you flip the paper over, it's not even going to show the other shades. It's only going to show the overlap shade. So number 2 on the homework on the worksheet, it's easy to do. It's already in slope-intercept form. I want to graph this top one in red. It crosses at 2. And from that point, you look at your slope, and the slope is 1 over 1 on the x. So you go up 1 over 1, up 1 over 1, up 1 over 1. You keep using that pattern to make the line as long as you want. You could even use that pattern backwards to make your line in the other direction. And this one is going to be a solid line because it does have a solid line underneath the inequality. So this is a solid line. Whoa, that's ugly. Arrows on it. And now you need to decide where your answers are at. They're either going to be on one side of the line or the other side of the line. So that's where the shading comes in. So let's pick a point and shade in that point. Let's pick the point 0, 0. If you check the point 0, 0, will it work? How do you do that? How do you check it? You plug it in, x is 0 and y is 0, and see if it's a true statement. So on the top one, if I were to plug in a 0 for y and a 0 for x, it's going to say 0 is greater than 2. What do you think about that? 0 is greater than 2. That's false. So 0, 0 does not work. That means that this dot right here is not an answer. That means that none of the answers on this side are going to be answers. None of the dots are going to be answers. Where are our answers at? They are on the other side of that red line. So you shade in that other side. Now let's do the same thing for the bottom inequality, and let's graph that one in blue. That one crosses at 3, so it crosses at 1, 2, 3 up here, and then from that point you're going to go up 2 over 3. Again, the slope is 2 over 1. The slope is 2 over 1, so we're actually going to go up 2 over 1. So from this blue dot, we're going to go up 2 over 1, and we end up right here, right on the edge. And you could use that pattern, but backwards, to extend the line as long as you want. And we're going to connect the dots, but is this going to be a solid dot or a solid line or a dotted line? Dotted. So I'm just going to put some dashes right between the dots that I already have. That's dotted or dashed, whatever you want to call it. So what we got to do is ignore the red graph, focusing on that blue line, and either shade in this side of the blue line or this side of the blue line. So let's test the point. Again, the point 0, 0 is awesome to test. And if you check it, you'll see that on the bottom equation, it's going to say 0 if you put it in place of y is greater than 2 times 0 if you put it in place of x plus 3. So 0 is greater than 3. What do you think? False. So this point 0, 0 does not work. So your answers are not on this side of the blue line. They're obviously on the other side of the blue line. So you go to your blue line and you shade in the other side. So where's the overlap piece? It'd be good to use a different colored pen. It's all of the overlap. This is all overlap right here. So this whole thing is shaded right there. Make sense? So it's important that you don't go past the blue right here on this side. It's blue, and then right here it curves this way. So the green is along this border right here. I hope that makes sense. Let's try the next one. The next one's very interesting. That's why I want to do it. You need to get both of them in y equals mx plus b form. So the top one, I want to go in red, and I want to get rid of that x by subtracting x and subtracting x, and I'll have y is greater than or equal to negative x plus 1. That's going to cross at 1, and from that point, I'm going to go down 1 over 1, and down 1 over 1, and down 1 over 1. Once again, it crosses at 1 because the b value is 1, and the slope is negative 1 over 1. That's why I'm going down 1 over 1, down 1 over 1. And you could use that pattern backwards to extend it the other way. And this will be a solid line. And now we need to shade in either one side of this red line or the other side of the red line. We're going to test the point 0, 0, the origin. So if I test the point 0, 0, you could test it right here on this x and this y, or you could go with the original equation, inequality, 0 here plus 0 there. I want to go with the original. If I plug in 0, 0, it's going to say 0 plus 0 is greater than or equal to 1. What do you think of that? Is that true or false? False. So this point doesn't work, which means that none of my answers are on this side. They're all on the other side. So the answers are up here, so I shade in the top, not get too crazy. And now let me go for the bottom one. The bottom one's a little bit weird, because when you get y by itself, when you subtract x and subtract x, you're going to have 2y is greater than negative x plus 1. Now, I still need to divide by 2, so I'm going to divide everything by 2. Divide by 2 here, divide by 2 here, and there's an invisible 1 in front of it, and divide by 2 here. So my blue inequality is going to be y is greater than negative 1/2 x plus 1/2. So this is going to be a little weird because the b value is 1/2. So it's not really 1 or 2, it's actually 1/2. So when I'm trying to get the b value, it's not really 1 or 2, it's 1/2, it's right here. So I need to put my dot at the halfway point from 0 to 1. Now from that point, what's my slope? My slope is negative half. So that means that from this halfway point, I want to go down 1 unit to the other halfway point and 2 units over. So it's from this halfway point down 1 unit to the other halfway point and 2 over. So my dot will end up right here in the middle. And you could keep going down 1 unit, which would be to the other halfway point, and then 2 over right there. Does that make sense? And you could go backwards. It would be right here, and it would be up here. And this will be a dotted line, so let me put some dots right there. This is ugly, sorry. So we need to ignore the red graph and focus in on the blue. And you're either going to shade in, the answers are either on this side of the blue or on that side of the blue. So let's test the point 0, 0 once again on the blue inequality, which is right here. So if I plug in 0 for x and 0 for y, you could do the modified one or the original one. It's fine either way. You're going to have 0 for y. It's going to say 0 is greater than negative 1/2 times 0 is still 0, plus half will be half. And is 0 greater than half? No. So 0, 0 did not work. So this point is not an answer. So where are my answers at? On the other side of the blue, so the top. So you're going to shade in the top part of that blue dotted line. Now the only thing that really matters is the overlap piece. And the overlap piece we're going to do in green, which is right here. And then bouncing off this way on the dotted. So everything up here is the overlap piece. Cool? I hope.